Hi everyone, welcome back. Our next speaker is actually coming from our partner Grid Dynamics. Grid Dynamics is a leading provider of technology consulting, agile co-creation and scalable engineering and data science services for Fortune 500 corporations undergoing digital transformation. They work in close collaboration with their clients on digital transformation, initiatives that span strategy consulting, early prototypes, and enterprise scale delivery of the new digital platforms. For our next talk, we have a bit of an intro and kind of want to paint you a picture. Nowadays, MLOps is one of the most popular topics in the data science machine learning world, as it enables businesses to reduce the cost of delivering new machine learning products and be more confident in them. In this talk, we'll discuss why it's important not to forget about MLOps from the beginning of a project, and we'll break down the main challenges that data science teams face in the development of new projects. So please welcome to the stage Dmitrii Fursov with his talk, Why You Need to Think About MLOps at the Beginning of Your Project. Thank you. It's here.
Okay, can you hear me? Yeah. 3 years ago, I had an experience with a very, very important project for my previous employer. We made a great model with good metrics, and it was really valuable for business, but it was not perfect in terms of operations and production. And you know what happened after? The team of 4 data scientists and ML engineers spent around 1 month on code refactoring and application of core MLOps principles. Of course, our customer was not happy with such changing of timeline, but finally it worked. That's why now I'm thinking about MLOps at the beginning of all my projects. And I suggest you do the same. My name is Dmitrii Fursov. I'm a senior data scientist at Grid Dynamics. I have more than 5 years of hands-on experience in data science and machine learning with different types of data science tasks. Today, I want to tell you about MLOps importance for projects from a data science perspective. So the topic of my presentation is why we need to think about MLOps from the beginning of your project, and I will try to answer on this question based on my own experience and on the best practices from the market. First of all, I would like to consider almost any ML project from a high-level perspective. So, from what any ML project consists? Usually, we start from some experiments. We want to understand what we can do with our data. We can have literally a lot of data, formalized tasks from our business teams, but we should build some kind of pipeline for our preliminary experiments. We need to understand which results we can obtain and what we should have for better results. At this stage, data scientists usually work in their favorite Jupyter notebooks, and you are very lucky if the code in these notebooks even looks like a bit like production. Okay, we have finished our experiments, trained some models, and now we are ready to test them. Next phase is testing. In machine learning projects, quality assurance isn't about the testing product so that it meets quality standard. QA specialists need to work collaboratively with engineers in iterating the ML models, test data, and algorithms. From my experience of working with QA specialists, there are 2 areas where QA teams are crucial to the success of ML projects. First one is error analysis, and second one, validating the solution on different environments. After successful completion of the testing phase, the product usually is moved to the production. Here we have a typical high-level pipeline, just as a reminder, for almost every project which is related to machine learning. We assume that training code will build the model which we can deploy in our service or application. Okay, let's give a definition. What is MLOps? We will consider MLOps as an engineering culture that includes the following practices. First one is continuous integration, or CI. In this stage, we perform the continuous testing and validating of code, data, and models. Second one is continuous delivery, or CD. In this stage, we perform the delivery of an ML training pipeline that automatically deploys another ML model prediction service. Third one is continuous training. This is a unique property for ML systems. At this stage, we perform automated retraining ML models for redeployment. And fourth one is continuous monitoring. At this stage, we perform the monitoring of production data and model performance metrics. It's very important to have all these core 4 principles covered while building a proper MLOps pipeline. And also, I need to highlight here that there is a huge difference between DevOps and MLOps. In DevOps, as a main unit, we consider a code. In MLOps, the core unit is a model and everything which is related to the model. And this is a really crucial difference between these two definitions. On this slide, we can see key phases of MLOps. In black boxes, I highlighted classic things which are related to almost every project. So data gathering, data analysis, data transformation preparation, model training and development, and model validation. And in yellow boxes, I highlighted things which are related to MLOps specifically. Model serving, model monitoring, and model retraining. And there are topics which MLOps includes in scope of the projects. Okay, let's consider how we can structure data science teams in organizations in terms of their culture of work. In a few next slides, I will use Google terminology because I found it simple, mindful, and very understandable. And Google calls it maturity of data science teams. Let's start from level 0. At level 0, every step is manual, including data analysis, data preparation, model training, and validation. It requires manual execution of each step and manual transition from one step to another. This process is usually driven by experimental code that is written and executed in Jupyter notebooks by data scientists interactively until a workable model is produced. MLOps level 0 is common in many businesses that are beginning to apply machine learning to their use cases. This manual data scientist-driven process might be sufficient when models are rarely changed or trained. But in practice, models often break when they are deployed in the real world, because the models fail to adapt to changes in the environment, or, for example, data also can be changed. Let's move to level 1. At this level, the steps of the ML experiments are orchestrated, and transition between steps is automated, which leads to rapid iteration of experiments and better readiness to move the whole pipeline to production. The model is automatically trained in production using fresh data based on live pipeline triggers. In level 0, you deploy a trained model as a prediction service to production. In level 1, you deploy a whole training pipeline, which automatically and recurrently runs to serve the trained model as the prediction service. Here also, you usually manually test the pipeline and its components. And you manually deploy new pipeline implementations. This setup is suitable when you deploy new models based on new data, rather than based on new ML ideas. And let's move to level 2. For a rapid and reliable update of the pipelines in production, you need a robust automated CI/CD system. This automated CI/CD system lets you, data scientists, rapidly explore new ideas around feature engineering, models, and hyperparameters of the models. They can implement these ideas and automatically build, test, and deploy the new pipeline components to the target environment. The diagram shows the implementation of the ML pipeline using CI/CD which has the characteristics of the automated ML pipeline setup plus the automated CI/CD routines. Setting up a CI/CD system enables you to automatically test and deploy new pipeline implementations. This system lets you cope with rapid changes in your data and business environment. Okay, this is good that we already know something about levels of maturity for data science teams. For example, for proof of concept type of projects, things from level 2 can take more than 30% of the total time of the project. Obviously, this is unacceptable, and we need to choose the level of MLOps penetration according to the project needs. If you know that your project will be complex and with a long timeline, at the beginning, it's reasonable to aim for level 1 tools and develop the project to level 2 gradually. Remember, you don't need over-engineering. So choose your necessary level of MLOps penetration according to your needs. Well, let's consider key benefits from MLOps in your project. First one, MLOps increases the productivity of data scientists and machine learning engineers. And it happens because we are creating automated pipelines. We have a lot of repetitive tasks in machine learning modeling. MLOps stand for automating the entire workflow of the ML model. And this saves time and avoids human-induced errors. So we can avoid wasting time on repetitive tasks and make value-added tasks. Next benefit is reliability. MLOps makes ML pipelines more reliable, human error will be less, and we can get real insights into the data. For reliable scaling, MLOps streamlines model management procedures. So as a result, the machine learning model we get as a product of MLOps has high quality and higher accuracy. And of course, it's also reliable. Next benefit is reproducibility. Automating ML workflows provided reproducibility and repeatability regarding how the machine learning model is deployed. This helps in becoming more productive by reducing the time to deploy models. Coding automation also makes the job of data scientists easier. And next one is monitorability. Through MLOps techniques, we get insights about model performance by retraining the model continuously to make sure that it gives the best output. And also, it allows us to send signals if there is any model drift. For example, if the model degrades below a predefined threshold. And cost reduction. I think it's most favorite words for almost any business. And let's figure out what I mean under cost reduction in terms of MLOps. So we can do it by reduction costs on the cloud infrastructure, because now we have a tendency that many businesses move their data pipelines to clouds, and it has a quite reasonable cost. So application of MLOps techniques allows you to reduce costs on cloud infrastructure because it reduces time which we spend on development and on work of virtual machines, for example. And faster time to market, faster process data to value. This is a result of described above benefits. This is what we get with reasonable usage of MLOps culture. And also, I want to say a few words about model testing and model comparison. Sometimes it's a really tricky question, and I would like to consider it as a part of MLOps culture. If you want to compare your models, you need to build the right pipeline for testing. And here we have two options. First, use classic A/B tests, and you can use all achievements from this scientific field to make your tests reliable and confident. And second option is giving a test to another model, which is called a multi-armed bandit. The main thing here is to do it in the right manner, because previously in my practice, I've met a lot of examples of wrong hypothesis testing. Usually it leads to wrong conclusions and bad decisions. But we don't want to make bad decisions, right? So if you know that in the nearest future, you will meet with model testing, spend your time on figuring out what you can use for proper testing. You can write your own framework for testing or use some tools from vendors. It depends on your needs, because we don't have here a unified solution. Okay, we considered why MLOps can be good for your project. Let's talk about possible problems without MLOps from a data science perspective. First one is data leakage. Quite common problem. It refers broadly to scenarios wherein a model makes use of information that is not supposed to have or would not have available in production. Usually it leads to too optimistic model performance estimates and poses serious downstream problems upon model deployment. Second one also is quite common, lack of training artifacts. Usually it leads to the impossibility of reproducing previous results. For example, data was updated and there is no opportunity to restore old version. But for example, we need to restore old model version and we can't do it. Third one is using model predictions without any checks. This is why I think error analysis is necessary. I also met a lot of examples when business blindly trusts to model predictions without any checks. So I think that it's okay to apply business rules to your predictions if it's needed, and don't hesitate to do it. Broken model evaluation is the next one. It also can lead to too optimistic model performance estimates. Fifth one, data drift or model drift, and you don't consider it during the project. I think this topic is very important, so we will talk about it in details a little bit later. And lack of documentation for data and model. Quite common things. For example, let's imagine the situation when we did some project. We stopped it by some reason, and after this, we returned to it, for example, after 3 months. And so we need to spend some time on figuring out what happened and what we should do. Well, let's talk about data drift more in details. There are many factors that can cause data drift, and one key factor is the time dimension. Let's give a definition of data drift. This is unpredictable, unannounceable, and unendable mutation of data characteristics caused by the operation, maintenance, and modernization of systems which produce data. This is a very common problem for tasks of demand forecasting. I think that this is one of the most popular kind of data science tasks which businesses is solving now. It's important to build a repeatable process to identify data drift, define thresholds on drift percentage, and configure proactive alerting so that appropriate action is taken. When data drifts is not identified on time, the predictions will go wrong, the business decisions taken based on the prediction may have a negative impact, so we can't trust our models. And of course, that's not great. Well, let's summarize. Why do you need to think about MLOps from the beginning? I guess that now we can answer on this question. So first thing which I want to mention, we want to make our ML more reliable and confident, as well as we want to avoid common mistakes in machine learning projects. And MLOps allows us to improve effectiveness of working of our data science teams by reducing costs and spending time on the project. And finally, it helps to reduce time to market value, which is very important for any business. Thank you for your attention. I would be glad to answer your question.
Hi, Dmitrii. Thank you for your presentation. Do we have any questions from the audience? No, it doesn't seem like we do. Once again, thank you very much for your talk, and hopefully we'll see you next time on our show,
Thank
on
you.
our program.